use. This question is from the database questions from IB DP1 DP2 program. So let's see what's there in the question. And the question says that a hot object may be cooled by blowing air past it. So this is the apparatus there. This cooling process is known as forced convection. In order to investigate forced convection, hot oil was placed in the metal can. So this is a metal can and oil has been placed. The can was placed on an insulating block and air was blown past the can. So this is the insulating block there, and then air is going over there as shown in the figure. So now the question starts here. The question says that a hot oil was stirred continuously and its temperature was taken every minute as it cooled. The graph below shows the variation with time of the temperature of the cooling oil. So this is the graph between temperature and the time. So it is thought that rate R of decrease of temperature depends on the temperature difference between the oil and its surroundings. The excess temperature, that is theta E, the temperature of surrounding was 26. So the question first, that is A, on the graph, draw a straight line parallel to the time axis to present the temperature of the surroundings. So we have to draw a line which will be telling the temperature of the surroundings, and temperature of the surrounding is 26. So we will be drawing a line that would be at 26. So this would be like, what will be the least count here? You can see that it is the 10 points, like this one box, this is 20 and these boxes are 10, so each box is of 2. So for 26 we need more 3 boxes, 1 2 3. So this will be 26. So now we need to draw a straight line from here, and the straight line would be like this. So this will be the straight line. Okay, so this is the first part that has been drawn. By drawing a suitable tangent, calculate rate of decrease of temperature for excess temperature at 50 degrees Celsius. So first of all, you understand that for 50 degrees of temperature, we need to add 26 degrees, making it total of 76 degrees Celsius. So now we will draw a tangent at 76 degrees because 26 is the surrounding temperature and for an excess temperature of 50 degrees. So now first of all we will locate where is 76. So here it is 70, and then it would be like one line is missing, I guess. So we will take it as 2. So 70, 72, 74 and 76 is like this. So we would be moving here. So this is 76. Now we need to draw a tangent. Tangent would be like this. We can little bit change accordingly if we think that it is not up to mark. So this will be the tangent at 76. So we got the tangent now, and by drawing the tangent, calculate the rate of decrease of temperature. So rate of decrease of temperature, basically we need to calculate the slope because our graph is between the temperature, that is degree Celsius, and the time. So now we need to calculate the slope. So let's first see 2 points. We can take this point. So this point will be, like 20 here, and it would be like 13. So one box here, like 10 boxes for 2, so 0.2, 0.5. So for 0.5 it is 0.5 or something else. No, Just wait. See, this is 1, 2, 3, 4, 5. So 1 by 5 is 0.2. So 0.2 is the one box. So we are here, like this is 13. So this point will be 13.5. This is the x-axis and y-axis will be 20. Okay. And now we can take any point here. We can take this point. So this point is like 2, comma, and this is here. So this is at 90. 90 plus 2 is 92. So now we can take the slope is equals to the y is 92 minus 20 and 13.5 minus 2. So now we will be requiring the calculator. If there is calculator already open, yeah, calculator is there. So 92 minus 20, 72 divided by, it will be 11.5. So it will be 6.2. 6.26 we can write. So this will be the slope. So by drawing a suitable tangent, calculate the decrease of temperature. So it's a negative slope. So we can say that calculate the rate of decrease of temperature for excess temperature at this. So this is 6.26. See, whenever you will use this, you will do this, there would be a range of values that would be applicable here. So in these types of questions, there would be numerous answers to it. So the B part, in order to investigate the variation with R of theta E, the graph of R against theta E is plotted. The graph below shows 4-pointed data uncertainties is not included. Using your data, plot the data point for corresponding at 50. So A2 they are asking. Okay, so first of all, using your answer to this, that the slope has been required and 50 plus 26, we have to plot the data point. First of all, we need to create a data point here. So you would be requiring a straight line here. So we will draw like this. Why it is not there like that? Okay, so this is the perfect straight line, and for point number 50 we can now calculate it. For 50 it is here, so it is in between, this line is missing here. So for first of all, we need to calculate that one box is up to what thickness. So we can see that 5 and 5 10, so this is 0.004. I have just divided it with 10. So this is this one box. So this point will be of half of that, so it will be 10, like 0.10, and after that two boxes. So point after that two boxes means this 0.008. So it would be 0.108. So this point is, so we can mark this point as 0.108, and this is at the 50 degrees. Then the uncertainty in the measurement of R at each excess temperature is plus minus 10%. On the graph, draw error bars to represent the error at temperature 20 and 81. So at 20, this point we need to calculate. So this point will be how much? We can take some another color to show this. Let's do it. So this is just one box. So it would be 0.044, this point. And the 10% of this, 10% of this would be the error. So what will be the 10% of this? 10% of this, you can use a calculator if you are a little bit confused about that. See, 0.044 into zero point 0.1. So 0.1 will be like 100 by 10 by 100 is a 10%, and it is 0.1 only. Yes, you're right. So it would be 0.004, which is a little bit more of 0.0044. So this is the error. So to plot this, we will go for only one box. I'll just enlarge this. Okay. So now see, this will be like this. So this is the error here, only just for one box. Now I'll again minimize a little bit, zoom out. Then now we need to plot it for 81. So 81 is here. So we will take some another color. This color is not that much visible. So here is 81. Let's see this, whether this is 81 or not, because this will be like 10 boxes for 20. So one box for 2. So 81 will be some in between of that. So this will be 81 will be in between of one box. So this point is already at the 81. So 81, we need 10% of that for the error, and that becomes like 10% of 81. It will becomes 8.1. So 8.1 is the error. So this is 0.04. So for 8.1 error, how many boxes we have to go to? Okay, oh, I'm sorry for that. Not this. Just wait. We need to, the error is over there. The error is not here, but on this side. So this is the 81. We need to calculate it here. Okay. Do not make mistakes like I was going to have that mistake. So first calculate this. So this will be 0.18, and after that we had 1 2 3 three boxes. So 0.18 plus 3 boxes, and each box is of 0.004. So what will be the value? We will say 3 into 0.004, this is this, plus 0.18, 0.192, 0.192. So this is the value of this point. Now we need error. 10% error is from the R value. Okay, they say that uncertainty is in the measurement of R, not at the degree Celsius bar. So we were having some mistake over there, but we got it right at the right time. So now 10% of this will be 10% 0.192 into 0.1. So this is the 10% of that, 0.0192. Now for this, now we need to see that how many boxes it would be. So it would be easier for us. So we will divide it with 0.004. So 4.8 boxes. So it means 4.8 box. So we will go like this because this is missing line, like 1, 2, 3, 4, and then this 5. This is also looks missing. So here also 4.8 because like 1, 2, 1, 2, 3, 4, like up to this, like this. So 4.8 boxes we have to come. Basically 5 box, 1, 2, 3, 4, little bit more. You can go. Okay. So this is the error part from 81st, 81 degree Celsius, and this was from degree 20. So this is the part second. After that, explain why the graph B, in the graph B supports the conclusion that excess temperature theta E is related to the cooling off rate of cooling R by the expression this. See, we will say it because R is directly proportional to it, because this we are having a straight line graph passing through the origin, so it's a straight line graph. So that's why it is support the formula. At high excess temperature, the equation 1 is thought to be invalid. Discuss whether the graph B provides any evidence for this suggestion. Yes, definitely you will say that when we go to the higher temperatures like this line doesn't pass from this. So that's the reason it is not valid for at the high temperature, but it just passed through the error point, that is the maximum error that can be made in measuring that. In the second experiment, the data is analyzed by plotting a graph of log r and against log theta e. On the axis below, draw the graph to show that the line that would be obtained. On the axis below, draw a sketch of graph. Okay, not that is not that. This is a sketch graph. No data points. Okay, so we have this equation log r k, log r k log theta e. Oh, sorry, no, not the log. That r is equals to k theta e. So when we will take the log, it will become log r equals to log theta e plus log r. So it would be like this. So it would be like this. In the second experiment, the data is analyzed by plotting the graph of log r and log e. Log e is logarithmic to base 10, that's okay. On the axis below, draw the sketch graph to show the line that would be obtained. So it would be like this, because there is log r, assuming the expression C1, this one, C1, this expression that we have already used is correct. State the gradient of the line of the graph. So we have to see what will be the gradient of the line. See now, this graph is like y equals to mx plus c, because log e is there, log e is there. So this x is log. So what is m here? M here can be 1. So we will say that the gradient here, that is the slope, will be 1. Also explain how the value of k is obtained. So k will be obtained like because this is k. Okay, this is k, not r. So we will say that the intercept on the y-axis, this is log k. So if this intercept is something, we can say c. So c will be equals to log k. So we can say that k will be equals to 10 raised to power c, or we have to take this anti-log here. So this is how we have to solve these questions. There might be some differences in the answers because they are theoretical questions and there is a range of answers when we talk of data. So when we talk of data, there is range of answers to it, and we have to precisely be in that range only if we want good marks, because if we would be nearer to that range we will get more marks. So hope you got everything from this video and this question has been solved properly up to your expectations. If you still have some doubts, you can just put it into the comment section and I would be then making this video again if there would be any issues with that. So thank you for watching this video.